Hi, I'm Luke, and my 2015 Hackaday Prize entry is analog.io. We hear a lot about the Internet of Things. Usually it's an evangelist from a big company like Intel, Microsoft, or Cisco talking about a refrigerator that could order us groceries. Then there's that latest Silicon Valley startup that just raised $5 million to develop a wearable computer for your dog and a button that helps you order pizza. I'm here to say that my vision for the Internet of Things does not involve keeping your fridge fully stocked with pumpkin spice lattes. The theme of the 2015 Hackaday Prize is to build something that matters. Rather than focusing on a solitary issue, I decided to build a platform that empowers a large community to go out there and do something that matters. Members of the analog.io community use it for energy and water conservation, home automation, monitoring solar energy production, or optimizing farm output through efficient irrigation and fertilization. Other analog.io users use it to monitor the efficiency of a green heating and cooling system. There's also room for fun, like monitoring the distance that your hedgehog ran or the number of times that your coworker says "your mom." Since I launched analog.io and joined Hackaday, 525 members have joined the site. They come from countries all over the world and have created over 80 unique data streams. Analog.io is about empowerment. I'm also developing hardware and RF systems to help people connect sensors to the internet. It started out with this 915 megahertz wireless radio and this Wi-Fi bridge. I then went on to develop this 2.4 gigahertz wireless sensor, which is designed to be ultra low cost and compatible with the Bluetooth low energy radios that are inside your phone. This means that with one piece of hardware that costs around $10, you can connect your own sensor, bridge it to the internet with your phone, and do your own IoT application. I would like to now show you a demonstration of all of this hardware working together in concert to do a fun demo. So what I have here is an array of sensor nodes. I have both the MSP430 2.4 gigahertz sensor node as well as some of the 915 megahertz sensor nodes all in this grid-like array. Over here in the corner is the hub that I have configured to receive both 2.4 gigahertz radio packets and 915 megahertz radio packets. And if you look closely, you can see an LED flashing when packets are received. Right here on the screen, you can see a grid. This is actually showing the temperature gradient between these items. And so if I reset the gradient, we can see all of the temperature data feed into the data. What I have here is a lighter, and so I'm going to place it on one of these sensors and start to heat up that sensor. Eventually the sensor will transmit a new value to the hub, and then we can identify that localized hotspot in the heat map. If I remove the heat again, it should take some time for the heat to dissipate and the gradient to fill back out. I can also use my lighter to heat up a different sensor. We can see that hotspot appear as well. So that's my demo. There's a lot more information in the project logs. I try to update that as much as possible. It's been my honor to be a semifinalist in the Hackaday Prize, and I hope to continue into the finals. I hope that everybody who is entering the Hackaday Prize has good luck, and looking forward to see who makes it to the final 10. Thanks a lot. Bye.